Assalamualaikum and have a good day. Professor Madati as Dr. Zulkifli bin Mohammed. My name is Muhammad Irfan bin Miskun. My student ID is 2018654012 from Group 4. Now I'm going to talk our project title, which is Slotted Link Mechanism. The slotted link mechanism is an example of quick return mechanism that can convert circular motion to reciprocating motion. The connecting slotted bar is driven with a horizontal constant velocity and it will turn back to the original position. A reciprocating rectilinear motion of a slotted bar is caused by the movement of the lead screw that powered by the motor. It is a reversible system in which the slotted bar may be moved by turning of the lead screw. So now let's move on to our problem statement. The rotation of the slotted bar mechanism is one of the sample of examining how kinematics have been used in dynamics. In this study, we are required to determine the angular velocity and angular acceleration of the slotted bar that is driven by the lead screw. It should be quite helpful to illustrate the motion of creating a slotted bar controlled by a lead screw model. Thus, the theoretical and experimental result should be evaluated to determine the accuracy of the student data collection. From the problem statement, we can identify the objective, which is to create the realistic model of the slotted bar with the rotation using the equipment and tools that are available. Second, to demonstrate the mechanism of a simple rotation of the slotted bar that controlled by the lead screw. And lastly, to compare the theoretical value from the manual calculation to the actual angular velocity and acceleration obtained from the experimental data. So this is our detail component that have been used in our project. It is divided to two components, which is mechanical and electronic component. For the mechanical component, it is including the lead screw, coupling, bearing, slotted bar, bottom bracket, and acrylic board. While for the electronic component, it is including the LCD display, Arduino Uno 3-axis accelerometer gyro sensor, sharp infrared IR analog range finder sensor, wires and connector, relay module, push reset switch, and lastly DC 12-volt motor.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Ahmad Aiman bin Wan Anwar. I will talk about design process. In design process, it is divided by two, which that me and my teammate draw the component at the SolidWorks and import the drawing from TracePad. These are some components that are designed in SolidWorks, which are bearing, acrylic box, lead screw, and slotted bar. Electrical components like LCD and Arduino Uno were just imported from TracePad only, since it's are complicated to draw.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fikri bin Zaman. And today I will present about the algorithm of the system. I will start with the program. So first of all, we include the button, wire, liquid crystal, sharp IR. So basically the input of the coding is the button, and then sensor which is we use sharp IR at pin A0, and angle sensor MPU 615 at pin A4 and A5. Okay, this is CW is for clockwise motor and counterclockwise motor at pin 7. So this is the code, and this is the motor for forward and reverse at few seconds and milliseconds. This is the program for the display formula LCD, which include the formula and the display of the LCD. So next I will proceed with the flow chart. So the process of it will read the button angle, distance, and show the display. So the read button will generate count, and if count is 1 or until 10, it will rotate clockwise or anti-clockwise for the time. After that, it will read back the angle button and show the display.
Assalamualaikum warahmatullahi wabarakatuh. My name is Kamarul Rizal bin Muhammad. So today I will present about the fabrication of the product. So the first product is the slotted bar part, and the first process is the marking and cutting process of the material, and the second one is the water jet cutting process by reflect the one-to-one drawing. So next we go to the acrylic body part for the fabrication of the product. So the first process we use is the marking and cutting process for the acrylic material by using the hacksaw cutting and also by using the cutter acrylic. So next is the drilling process on the acrylic for the electronic component. So for the last is the assembly and wiring for the fabrication part. So the first is the assemble for the mechanism part, and the second one is the wire sensor testing as shown in the figure, and also the commissioning, and lastly finishing and testing the product. For the theoretical calculation as shown in the figure, so we have 3 fixed value. So for the calculation, angle used for the distance is 5 cm for the example, and the angle we get is 26.56 degree. Next calculation is for the angular velocity. We use the data and insert to the formula, and we get the angular velocity is 0.296 radian per second. And for the angular acceleration, we use for the angular velocity data, and we insert to the formula, and we get the negative 0.088 radian per second squared.
Warahmatullahi wabarakatuh. My name is Muhammad Sakali bin Masha. Okay, I will discuss about the result and discussion for this project. Okay, on the left is the graph of tune phase 1 theoretical, tune phase 2 and before tuning, and the right one is the before tuning and tune phase 2. Okay, this is the final result that we get from this project. That is tune phase 2 and theoretical. Okay, as you can see that the percentage error for these two is from 0% to 8%, so it's not higher than 10%. Also, this is the best result that we get from this project. Okay, for discussion, this project require a rotation and linear motion. The data acquired in this project is angle of the slotted bar when the lead screw move in the certain distance, that are 5 distance, that 5 cm, 10 cm, 15 cm, 20 cm and 25 cm. And then the angle is used to calculate the angular acceleration and the angular velocity. Okay, the capacitor was installed at the sensor connection to stabilize the voltage when produced by the sensor. Okay, the replication process also used to decrease the error. What is the replication process? Replication process is a repeating and a measurement several times and obtaining the average. Okay, that's all from me.